Hi everyone, this is Glenda Ganzon and welcome to my Human Anatomy and Physiology class.
Kick.
And for today's lesson, I'm gonna be discussing the requirements for human life. Humans have been adapting to life on Earth for at least the past 200,000 years. Earth and its atmosphere have provided us with air to breathe, water to drink, and food to eat. But these are not the only requirements for survival. Although you may rarely think about it, you also cannot live outside a certain range of temperature and pressure that the surface of our planet and its atmosphere provides. So I'm going to be discussing the 4 requirements for human life. The first and the most important requirement for human life is oxygen. We know that we cannot live without it. Atmospheric air is only about 20% oxygen, but that oxygen is a key component of the chemical reactions that keep the body alive, including the reactions that produce ATP. Brain cells are especially sensitive to lack the oxygen because of their requirement for a high and steady production of ATP. Brain damage is likely within 5 minutes without oxygen, and death is likely within 10 minutes without it. The second requirement for human life are nutrients. A nutrient is a substance in foods and beverages that is essential to human survival. The 3 basic classes of nutrients are water, the energy-yielding and body-building nutrients, and the micronutrients. Micronutrients are vitamins and minerals which can be found in the foods that we eat. But the most critical nutrient is water. Depending on the environmental temperature and our state of health, we may be able to survive for only a few days without water. The body's functional chemicals are dissolved and transported in water, and the chemical reactions of life take place in water. Moreover, water is the largest component of cells, blood, and the fluid between cells, and water makes up about 70% of an adult's body mass. Water also helps regulate our internal temperature and cushions, protects, and lubricates joints and many other body structures. The energy-yielding nutrients are primarily carbohydrates and lipids, while proteins mainly supply the amino acids that are the building blocks of the body itself. You ingest these plant and animal foods and beverages, and the digestive system breaks them down into molecules small enough to be absorbed. The breakdown products of carbohydrates and lipids can then be used in the metabolic processes that convert them to ATP. Although you might feel as if you are starving after missing a single meal, you can still survive without consuming the energy-yielding nutrients for at least several weeks. Water and the energy-yielding nutrients are also referred to as macronutrients because the body needs them in large amounts. In contrast, micronutrients are vitamins and minerals. These elements and compounds participate in many essential chemical reactions and processes such nerve impulses, and some, such as calcium, also contribute to the body's structure. Your body can store some of the micronutrients in its tissues and draw on those reserves if you fail to consume them in your diet for a few days or weeks. Some other micronutrients, such as vitamin C and most of the B vitamins, are water-soluble and cannot be stored, so you need to consume them every day or 2. The third requirement for human life is the normal range of temperature. You have probably seen news stories about athletes who died of heat stroke or hikers who died of exposure to cold. Such deaths occur because the chemical reaction upon which the body depends can only take place within a narrow range of body temperature. from just below to just above 37 degrees centigrade. When body temperature rises well above or drops well below normal, certain proteins, or what we call as enzymes, that facilitate chemical reactions lose their normal structure and their ability to function, and the chemical reactions of metabolism cannot proceed. They said the body can respond effectively to short-term exposure to heat or cold. One of the body's responses to heat is, of course, sweating. As sweat evaporates from skin, it removes some thermal energy from the body, cooling it. Adequate water is necessary to produce sweat, so adequate fluid intake is essential to balance the loss during the sweat response. Not surprisingly, the sweat response is much less effective in humid environment because the air is already saturated with water. Thus, the sweat on the skin surface is not able to evaporate, and internal body temperature can get dangerously high. But the body can also respond effectively to short-term exposure to cold. One response to cold is shivering, which is random muscle movement that generates heat. Another response is increased breakdown of stored energy to generate heat. When that energy reserve is depleted, however, and the core temperature begins to drop significantly, red blood cells will lose their ability to give up oxygen, denying the brain of its critical component of ATP production. This lack of oxygen can cause confusion, lethargy, and eventually loss of consciousness and death. The body responds to cold by reducing blood circulation to the extremities, the hands and feet, in order to prevent blood from cooling there and so that the body's core can stay warm. Even when core body temperature remains stable, however, tissues exposed to severe cold, especially the fingers and toes, can develop frostbite when blood flow to the extremities has been much reduced. This form of tissue damage can be permanent and lead to gangrene, requiring amputation of the affected region. And the last requirement for human life is the normal range of atmospheric pressure. Pressure is a force exerted by a substance that is in contact with another substance. Atmospheric pressure is pressure exerted by the mixture of gases, primarily nitrogen and oxygen, in the Earth's atmosphere. Although you may not perceive it, but atmospheric pressure is constantly pressing down on your body. This pressure keeps gases within your body, such as gaseous nitrogen in the body fluids, dissolved. If you were suddenly ejected from a spaceship above Earth's atmosphere, you would go from a situation of normal pressure to one of very low pressure. And the pressure of the nitrogen gas in your blood would be much higher than the pressure of nitrogen in the space surrounding your body. As a result, the nitrogen gas in your blood would expand, forming bubbles that could block blood vessels and even cause cells to break it apart. Atmospheric pressure does more than just keep blood gases dissolved. Your ability to breathe, that is, to take in oxygen and release carbon dioxide, also depends upon a precise atmospheric pressure. Altitude sickness occurs in part because atmosphere at high altitudes exerts less pressure, reducing the exchange of these gases and causing shortness of breath, confusion, headache, lethargy, and nausea. So these are the 4 requirements for human life. Number 1 is oxygen. Number 2 is nutrients. Number 3 is the normal range of temperature. And the last one, number 4, is the narrow range of atmospheric pressure.